In this lesson, we are going to do a quick review of Pythagorean Theorem, as well as take a look at Pythagorean triples. So for both of these examples, we're going to use Pythagorean Theorem to solve for the unknown side. In the first question, the unknown side is the hypotenuse, and in the second one, the unknown side is one of the legs. So we'll go through the difference between the two before we move on to the triples. So first of all, we're going to start by finding the hypotenuse. So directly across from the 90-degree angle, that's our hypotenuse, and we'll label that as C. We'll label 7.5 as A and 6 as B. Then we'll move on to our Pythagorean theorem and substitute in what we know. So our A value is 7.5, and we'll square that. B is 6, and C is our unknown. So now we're going to square each of our values. So we have 7.5 squared is 7.5 times 7.5. We get 56.25. Plus 6 squared is 36 equals C squared. Add your two values together to get to 92.25. And then square root both sides. So C equals 9.6. In the second example, where one of our legs is missing, we still want to find the hypotenuse. So again, directly across from that 90-degree angle is our hypotenuse. That will be in our C position. I'm going to put X in our A and B as 8.6. So moving on to our Pythagorean theorem. Our A is the unknown side. So we'll have A squared plus 8.6 squared equals 12.3 squared. The hypotenuse always has to be in the C position. So square the values that we know. So 8.6 squared is 73.96. 12.3 squared is 151.29. Now, because our two values are on different sides of the equal sign, we need to subtract the 73.96 so that our A squared is by itself. So when we do that, we'll have A squared equals 77.33. And then we'll square root both sides of our equation. So we'll get A equals 8.79, but our 9 rounds our 7 up to an 8. So our A value is 8.8. Okay, we'll take a quick look at a word problem. So a rectangular field measures 150 meters long by 90 meters wide. How far is it if you walk diagonally from corner to corner? Okay, so we're just going to draw a little diagram. And our field is 150 meters long and 90 meters wide. So if we go from corner to corner, the diagonal, we're looking for that line there. So we can use Pythagorean theorem because we do have a right triangle. And directly across from our 90-degree angle is our hypotenuse, which will be our C value. So with Pythagorean theorem, I'm going to call 90 our A and 150 our B. So we'll have 90 squared plus 150 squared equals C squared. So square the numbers that we've got. So 90 squared is 8100. 150 squared is 22,500. Then we're going to add our two values together, and we will get 30,600 equals c squared. We're going to square root both sides, so c equals 174.9 meters, and that would be the distance from one corner to the other corner diagonally across the field. So the next example that we're going to look at, or the next part that we're going to look at, is a Pythagorean triple. And a triple is a set of three positive integers. So that would be a positive whole number. So x, y, and z. And this is going to satisfy the Pythagorean theorem, which means that when we solve the left-hand side of the equation, we're going to get, or we should get, the same value as the right side of the equation. So we'll take a look at an example. So the first one says, determine if the following side lengths will produce a right triangle. So for our A and our B, it doesn't matter if we pick the 8 or the 6, but it does matter what number we choose for our C value in Pythagorean theorem, because the C is the hypotenuse, and the hypotenuse is always the longest side. So the first thing that we need to look at is, what is our largest number that will represent the longest side? So that's going to be 12. So we want to call that our C value. The other two numbers that are smaller, these can be A or B, it doesn't matter. So you could call 8 the A, or you could call 8 the B. It doesn't really matter. So we'll just say 8 is the A and 6 is the B. So now we want to go to our Pythagorean theorem. And this time we're going to substitute all three of the numbers into our A, B, and C. So we're not trying to find one of the values. We have all three values, and we want to see if it actually creates a right triangle. So our A is 8. So we'll have 8 squared plus 6 squared equals 12 squared. Now we're going to square everything. So 8 squared is 64. 6 squared is 36, and 12 squared is 144. So now we're going to add together our 64 and our 36. When we do that, we get 100, and our other side just stays the same as 144. So now notice that our two values do not equal each other. So when they do not equal each other, this does not create a right triangle. So Pythagorean theorem does not work. And in order to use Pythagorean theorem, we have to have a right triangle. So we don't have a right triangle represented by our three values of 8, 6, and 12. Okay, looking at our last example. Again, we're going to determine if the following side lengths will produce a right triangle. So just like the last question. So again, the first thing we need to do is find our hypotenuse, which is the longest side. So choose the largest number, which will be 13, and that is going to be our hypotenuse. That is going to be our C value. Okay, again, I'm going to call 5 our A value and 12 our B value. Again, those can be switched. It doesn't matter. And now substitute in the numbers that you know. So our A is 5, so we'll have 5 squared plus 12 squared equals 13 squared. Okay, square all of your numbers. So 5 squared is 25. 12 squared is 144. And 13 squared is 169. So we'll add together our 25 and our 144. and that equals 169, and our other side stays as 169. So in this example, our two values do equal each other. So that tells us that 5, 12, and 13 are a Pythagorean triple that satisfies the Pythagorean theorem. So when your two sides equal each other, then yes, this does create a right triangle.